In this video, we're going to do an overview of quadratic functions. Quadratic functions are any function that may be written in the form y equal ax squared plus bx plus c, where a, b, and c are real coefficients, but the coefficient a is never 0. This means we always have an x squared term. Let's look at two examples and one non-example. Y equal 2x squared is clearly a quadratic function. It has the x squared term. It doesn't have the bx or c terms. That's because b and c are 0. And that's okay. On the far right, we have y equal x plus 1 times x minus 3. That doesn't look like the correct form, but we can make it into the correct form simply by boiling it out and getting x squared minus 2x minus 3 after simplifying, and that does fit the form. The middle function is not a quadratic function because of the 1 over x term. 1 over x is the same as x to the negative 1 power, and our quadratic form does not have such a term in it. The graph of a quadratic is called a parabola. You have probably heard the term parabolic. It comes from the shape of this graph. The high or low point of the parabola is called the vertex. Here I have 4 different parabolas graphed. 2 are upside down and 2 open up. The ones that are upside down have a vertex that is the highest point, and I have 2 of them like that. And the 2 parabolas that open up have a vertex that is the lowest point. The standard form of a quadratic function is y equal a times quantity x minus h squared plus k. Any quadratic function written this form will have the same shape as y equal ax squared. Furthermore, the vertex will be shifted from 0, 0 to the new location as determined by the values of h and k. And here I have an example. We're going to graph y equal negative 2 times quantity x plus 4 squared plus 1 and give the vertex. Well, using those function shift rules that we learned about in the previous section, this is going to be a shift of negative 2x squared left 4 and up 1. Because we've just replaced x with x plus 4, and we've added 1 to the formula. Negative 2x squared is the parabola where we go over 1 to the right, down 2. We take the upside down stretched parabola and move it to the new location. The vertex goes 4 units to the left and 1 up from 0, 0 to negative 4, positive 1. And then from the vertex we move 1 unit over, down 2. To get another point, 1 unit over to the left, down 2 to get another point, and there's our parabola. In the previous video, I did quite a few examples using the function shift rules and this standard form, so go back and refer to those examples as needed. Okay, now let's graph y equal 2x squared plus 8x minus 5. How are we going to do that? This is not in standard form. Can we write it in standard form? The answer is yes. We can do this by completing the square on the x terms. And here's how we do it. First, we factor the coefficient on x squared out of the first 2 terms. We factor the 2 out of the x squared and the 2 out of the 8x. Well, 2 times 4x makes the 8x. So we have 2 times the quantity x squared plus 4x minus 5. Now we want to complete the square on the x squared and x terms and make it into a perfect square that we can factor, and that'll give us our standard form. Well, now to complete the square on those terms, we take half of the coefficient on x, which is 4, and half of 4 is 2. 2 squared is 4, and that's the magic amount we add inside the parentheses. Now if we add 4 to the right side of the equation, what we're really adding is 2 times 4, or 8. We could add 8 to the y, but we don't want to do that here. What we really want to do is subtract 8 on the same side of the equation. So we subtract from the 5 2 times 4. Well, now we can simplify that a little bit. The negative 5 minus 8 is negative 13. Okay, now we have a perfect square. X squared plus 4x plus 4 factors as x plus 2 times x plus 2. So we can write this as y equal 2 times x plus 2 quantity squared minus 13. That's our standard form. The graph will be a shift of 2x squared, and we're moving that vertex left 2 and down 13. And here's our graph. I have the parabola y equal 2x squared graphed as a reference. with the vertex 0, 0 and the 2 points 1, 2 and negative 1, 2. Just move all three of those points 2 units to the left and down 13, and we get our parabola with the 3 points shifted shown in red. And now I'm going to do another example that's a bit more challenging. We're going to write y equal negative 3x squared minus 4x minus 1 in standard form by using that process of completing the square. The first step here is to factor out that coefficient on x squared out of the first two terms. We factor the negative 3 out and we get the quantity x squared plus 4/3 x. Why 4/3 x? Because 4/3 times negative 3 multiplies out to the negative 4 that we want for negative 4x. And then I have a note on the side here, stop. Does all of this multiply out to the original equation? That's how you check your work on this process. The next step is to complete the square inside the parentheses. And we use this process of taking half of the coefficient on x, half of 4/3 is 2/3. And when we square 2/3, we get 4/9. 2/3 times 2/3 is 4/9. That's the magic amount that makes us have a perfect square. Well, when we add 4/9 inside the parentheses, and we're multiplying 4/9 times negative 3, what we've really done is subtracted 3 times 4/9. To keep the equation from being changed, we have to add 3 times 4/9 on the same side, and that's what I have shown here. And again, I have a note, stop. Does it all multiply back out correctly? The two quantities of 3 times 4/9 cancel each other and don't change the equation. Now we can factor the perfect square. And that trinomial factors as x plus 2/3 times x plus 2/3. Remember, it always is going to factor as x plus the square root of what you added inside the parentheses. The square root of 4/9 is 2/3. So we have x plus 2/3, x plus 2/3, and then we have minus 1, and then plus 12/9. We can simplify this by writing x plus 2/3 as x plus 2/3 quantity squared. Negative 1 is negative 9/9 added to 12/9 is 1/3, and we get our final result of y equals negative 3 times the quantity x plus 2/3 squared plus 1/3. As an alternative to completing the square, you can use something I call the vertex formula. And this formula says that if you have a function in the form y equal ax squared plus bx plus c, then the vertex will be located at x equals negative b over 2a and y equals f of negative b over 2a. And what that means is you take that x value that you found and plug it back in and calculate your y value. Let's try this on the previous problem. We're going to find the vertex of y equal negative 3x squared minus 4x minus 1. Well, since this function is in the form we need here, we take the values of a and b and plug them in. A is negative 3, b is negative 4. So x is negative b over 2a, which is negative of negative 4 over 2 times negative 3, and this simplifies to negative 2/3. We plug the value negative 2/3 back into the function. We get 3 times negative 2/3 squared minus 4 times negative 2/3 minus 1. And all of this simplifies to y equals 1/3. So we get a vertex of negative 2/3, 1/3. Well, that's exactly the same vertex we got from the previous process. When we completed the square, we got y equal negative 3 times x plus 2/3 quantity squared plus 1/3, which would mean we'd have a quadratic function with a vertex of negative 2/3, positive 1/3, with the shape determined by negative 3. And notice something, the negative 3 of our completed squared form matches the negative 3 of our equation we just worked with. So that value a does not change. The value a in the form ax squared plus bx plus c determines the shape, and the vertex you get determines the shift you have. So you could actually reconstruct the standard form using this shortcut formula because we have the value of a equal negative 3, we have the value of h, which is negative 2/3, and we have the value of k, which is 1/3. In this last example, we're going to look at an application of quadratics. The problem here is the height h of t of an object thrown straight up into the air is given as a function of time as h of t equals t times v minus 16t, where v is the initial velocity in feet per second. If the initial velocity is 50 feet per second, what is the maximum height obtained? Well, the first thing we do here is let v equals 50, and we plug that in, and we get the function h of t equals t times 50 minus 16t, and we can rewrite this as h of t equals negative 16t squared plus 50t. Now this is really the same thing as y equal negative 16x squared plus 50x. What we're going to do here is find the x value that gives us the maximum y value. Well, this is a parabola. In fact, it's an upside down parabola. So the largest value of h of t is going to occur at the vertex. Well, the vertex is the value where t equals negative b over 2a using the formula we just looked at, the shortcut formula. We plug our value of b equals 50 and our value of a equal negative 16 into that vertex formula, and we get t equals negative b, which is negative 50 over 2 times a, or 2 times negative 16. So this simplifies to 50 30-seconds, or in decimal form 1.5625 seconds. We plug that value back into our function and we get h of t, or in other words our y value, is negative 16 times 1.5625 squared plus 50 times 1.5625, and that simplifies to about 39 feet. So our answer here is the maximum height is 39 feet.